Are you done? Yeah. You can turn it in. You want to hand it in? Or you want to wait?
No,
You sure? Okay. Thank you. You have 5 more minutes. Thank you. You have 4 minutes, so if you want to try it, you can. Thank you. Thank you. All right, thank you. Thank you. 1 minute. Thank you. Thanks. Okay, that's time. Anybody else? You have a chance to do a little bit? Yeah. Okay. Okay, that's it. Do you want me to go through it or no? Yes? Okay, I'll go quick. All right, so the first one, you're going to take this, you're going to convert it to a decimal, 0.04. You're going to multiply it times 3. That's going to tell you how much salt you have, right? So what is that? 0.12. 0.12. So you have 0.12 liters of salt. Now, when you add these two together, you're going to have 3 liters plus 4 liters. You're going to have 7 liters of solution. That's kind of the obvious part of the question. The next one, what's the percentage of salt? Well, you have 7 liters, and 0.12 liters of it is salt, so you do 0.12 divided by 7, and whatever that came out to be. 1 point something? 1.7-ish? Okay. So it comes out to be, we think, about 1.7%. Okay, that's the first part. This one right here, you plug in 3 into this, you get what? 9 minus 4 times 3, 12, gives you negative 3. And then here you plug in negative 3 squared, still 9, minus 4 times negative 3, so this is 9, plus 12, that's 21. So you should get negative 3 and 21. This one, f of negative 2. Did you get this one right? No?
I don't know. I hope I did.
Okay, so you go to negative 2. You try and find the value. It should be negative 1. And then 1. And you go up, right, 2. And then this is asking for the x that gives you a y value of 1.
0.
And that happens right here. And that happens when x is 0. Okay. That's it. That's the quiz. Okay, so I think that the homework is getting frustrating for some of you because they don't match up. The homework packet that you bought at the bookstore, right, had some questions about domain and range that I did not cover in class. So if that happens again, if I haven't talked about it in class, then, you know, ignore it. And it would be better for you to not invest time in that and just ask me next class than to go try and figure it out on your own, okay? I've already looked at the factoring in the next few sections, and they match up pretty good. So we shouldn't have that issue again. I apologize. All right, anything else you want to discuss before we get into today's stuff? All right, so we're going to try at the end of class to have another quiz, but it'll be more of a group quiz. Just like a credit almost, just for being here and breathing. All right, so it'll kind of offset if you didn't do well on that one. I'd like to get 2 grades in today for this week, but it'll be over what we do today. All right, so please pay attention, ask questions. All right, so what were we doing last time? Do you remember? We were trying to factor by grouping. And we did greatest common factor first. We said you always try that. And then we did a grouping problem. So we're going to pick up with that. Let's take a look at this problem. 30x squared plus 9xy minus 20x minus 6y. And the instructions here are to factor. So when it comes to factoring, I'm going to write this down on the side. You're not going to be able to see it on camera. But when it comes to factoring, the first thing we always try is what? GCF. We always see, is there a greatest common factor? So do we have a greatest common factor here? Start with the numbers. Is there a number that goes into 30, 9, negative 20, and negative 6, all at the same time? No, I don't think we're going to get anything, right? All right, 2 doesn't go in there. 3 doesn't go. 2 doesn't go into the 9, right? 3 doesn't go into the 20, and you could keep trying. You're not going to find anything. All right, how about x's? Do we have x's in all the terms? No. Do we have y's in all the terms? No. So we do not have a GCF. All right, so the next thing that we do is we ask ourselves, how many terms do we have? Well, how many terms do we have? 4. And whenever we see 4, we're going to try grouping, right? So I'm going to put that under here. If 4, then try grouping. I put try there because grouping does not always work. Sometimes it fails, but for this class, it'll most of the time work, all right? All right, so how did we do the grouping last time? What was it? Cut it in half, right? Where do I do that?
Before the subtraction.
Before the subtraction, right after the last variable or number right here. Slash that thing in half. And then, where are all your name tags? Y'all have them? Come on, break them out. You lost yours? I have more. I'm only giving these out because if I'm going to do it one of these days, I'm going to give a quiz on who has their name tag. You need one? All right. So consider this required material. You need marker? Marker? Here we go. Heads up back there. Marker. I'm going to throw it in the middle. Good catch. Marker, you got one back there? Okay. All right, so what do we do on the first two terms? We do GCF on just the first two terms. So do we have a number that goes into both of these? The largest one you can find is 3, so we put a 3 here. And then we look at the variables, x. What's the most factors of x that we have in both of them? X. Just one single x. How about y's? No, I don't have a y in both. So after this, I put a what, Nautica? Parenthesis, good. You know, I picked on you last time, never mind. Erica? After the parenthesis, how many terms am I going to have in here, Erica? 2, right. How do you turn 3 into a 30, Erica? Multiply by what? 10. And then what else am I missing here? An x, good. And then a plus sign, and then what do I need to turn the 3 into a 9? 3, and anything else? A y, because I'm missing a y. Good. That's it, right? Is that all right? So you can always just double check, just multiply this through, and you should get back those two terms. After I'm done with that, Rebecca, you look like you want some of this. What would you do here? GCF here, and what do you see? 2. 2? Okay, so let's put a 2 out here, all right? Let's just put 2 because that's what you said. And then parenthesis, and then you would have to put what here to get back this? Negative 10x, right? Because you said 2, right? Does everyone see that? I would need a negative 10x here. Now, there's a little bit of a problem we should see right here. And that's, in order for grouping to work, what's in this parentheses must match exactly with what's in this parentheses. And it's going to be off a little bit, right? By the negative sign. So instead of pulling out a positive 2, let's pull out a negative 2 instead. And now when you do this times 10x, you will get at least these two first pieces to match, right? And now what would you need to multiply negative 2 by to get negative 6? Positive 3. And you also need a y. So plus 3y. And fortunately for us, these two match, right? If these two do not match, and there's no way that you can like tweak it to make it work, this grouping method fails. But in this case, it didn't. So, you want to do it? Caesar. What would you write next, Caesar? What would you write?
Parentheses 10x plus 3y.
10x plus 3y, close it off, and then parentheses 3x minus 2. Exactly. Perfect. So all we're doing is whatever matches, right? We like pulled it out, which is this. And then what's left in here are the two pieces that were in front. And at that point, we are factored. Okay? Now later on, what we would do is we would look at this and we would look at this and we would see, can those factor? But we haven't talked about two-term factoring yet. We actually are starting with four-term factoring, which seems like we should start with two, but we start with four. Four is going to help us do three terms. And then for the two terms, there's special formulas. Yes?
I was just gonna ask, like, what on the original, like, can you ever like rearrange those?
You could, and sometimes it'll work, sometimes it won't. Caesar was asking, like, could you like put the maybe the 20 minus 20x here and like the 9xy there and try it? Yes, you could. All right, let's do another one. Get some larger numbers here. 56x squared plus 24xy minus 70x minus 30y. John Paul, our first step is to always do what?
Split it.
Split it before that.
Factor out the greatest.
If we have one, right? So if we have one, we always want to check for this, all right? Always check for this. So do we have a common number that goes into all of those? Hey, they're all even, aren't they?
2.
We do have a 2. Agreed? Anything bigger than 2? Does 3 go into all of them? I don't think 3 goes into this, does it? No. 4, does 4 go into all those? No, 4 doesn't go into 30. 5 doesn't go in. 6? Let's start with the 2. Maybe if we look at the 2, it'll help us look at the remaining numbers and see if something factors out. Any variables? No? You don't have x's all the way through. You don't have y's all the way through. So 2 is the only thing I can pull out. What is left? How many terms will I have? Alex, how many terms am I going to have? If I'm pulling something out, how many should I have in here? 4, right? 1, 2, 3, 4. However many I started with, that's how many should be in there. So turn 2 into 56, you multiply by 28, you still have x squared, 12xy, 35x minus 15, right? That's a 2 taken out of everything.
15y.
Y, thank you. That would have caused some problems later. All right, we good? Now, looking at these again, I don't think there's a number that's going to go on all those. In other words, I think the 2 was enough, right? So now we look at what's in the parentheses. We recognize that there's 4 terms, and then we slash it right after the second term. And we're going to do grouping on those. And don't forget, we've got that 2 sitting on the outside of everything. Don't just like forget to write it. It's there. So watch how I write this. 2 parenthesis. And then I'm going to pull a GCF. I'm not going to. Kathleen is going to pull a GCF out of the first 2 terms. You don't want to? No. Okay. So let me help you, Kathleen. What number can you think of? Can you think of a number that goes into both of these? Oh, 4, I think so, right? Is that the biggest one? I think that might be the biggest one. So try it. Write a 4 down. What else do they have in common, Kathleen? Just single x. How about y's? Do they both have a y? Nope. So we're done? I don't want to freak you out too much, so I'll move on. Carlos, how many terms are we going to have in here, Carlos?
2.
2, because we pulled out of this, right? Okay, what's going to be here, Carlos?
7x.
7x, and then you want to keep going?
Yeah.
What do you got?
3xy.
3xy. We have an x out here, don't we?
Oh.
Right? So all we need is an xy. We already have the x, so you'll just need the y,
Okay.
right?
31.
Okay. Good. Now look, what I've been telling you is that the next thing you do is pull a GCF out of this, right? But there's kind of a different approach if you want to try this. You don't have to, all right? But just see if you like this or not. What do I have to have in here for this to work? 7x plus 3y. That's the only way it's going to work, right? So let me just try 7x plus 3y here. And now let me try and think of something that I could put out here that would turn this into this and this into this. -5, right? Do you see the difference between that and the other way? Your choice, okay? If you put this down here and you can't come up with a number or something that's going to do this, then the grouping fails. Any questions on what I've written?
So either way, they're both going to have 7x plus 3y.
But either way, that's what you have to have in order to continue using the grouping method. Yeah. Oh yeah, that was only for the quiz. Sorry, that was only for the quiz. Did I answer your question, Amber?
Yes.
Okay. Now I am missing something here. I need one more parenthesis.
Don't you do like brackets if it's like more than one?
That's a good question. Honestly, yes and no. Brackets and parentheses are exactly the same thing, but they use brackets kind of further back to kind of help you. So like, let's say you're doing like 2 plus 1, okay? Then you do plus 4, and then that, you want that times 2, but then you want to add 7 to that, and then what they do after brackets? They would use the brace, right? And then, so you could see like, okay, you do the brace, then inside do the brackets, then inside do the parentheses. But that was just to help you see like outside in. But what if I wanted to keep going? Like, what symbol am I going to use now? So parentheses are exactly the same thing. If you replace all of these with parentheses, it's the same thing. So using parentheses is more advanced than brackets, braces, and parentheses. Does that make sense? Okay. Now what? Distribute, well,
You would leave the 2 out?
leave the 2 out because that's factored out, right? We want this thing factored. So leave the 2 out there. What does all of this in here turn into? So I'm going to write that down over here. We still have the 2 out there, right? And then parentheses what? 7x plus 3y. Close it. Parentheses again. 4x minus 5. Now I heard some other people say this. I think this is where they were going with it. Is that correct?
Yes.
Yes, you can do either way. Those don't matter. That order doesn't matter because it's multiplication, right? Multiply, 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 multiply. So either one of these are your answers. Yes?
Would the 2 distribute to both of them in that scenario?
That's a great question too.
Because I feel like both those parentheses should have an additional set of parentheses.
That's a great question. What do y'all think? Does that 2, if I asked you to go ahead and pass this 2 through, would the 2 go through here, here, and then here, here? Or would it only go through one of them? Only this one? But what if you wrote it this way? It would go through this one and not that one. Does it matter? Turns out it doesn't matter. The 2 would only go to one of the parentheses. You would have to choose. It wouldn't matter which one. And here's the reason why. You can just think back of something more simple. What's 2 times 3 times 4? How do you do that? 4. That's 2 times 3, which is 6, and then times 4, which is 24, right? You do not do 2 times 3, then 2 times 4, do you? No, you don't do that. And that's the same thing. 2 times 3 times 4, you don't go 2 times 3 and 2 times 4. That answer your question? Kind of? You don't seem satisfied.
I know. Well,
It's
I
mo-
feel like if you put both of the parentheses in another parentheses, you would then have to do those first, do order operations, and then just multiply that. Which would be the
Well, it wouldn't, because it's multiplication, it won't matter. Look, if you put a set of parentheses here, it doesn't change the problem, okay? It's still going to give you the same answer. You still get the same result. Because multiplication, it doesn't matter what order you do this. If you have 3 things being multiplied, I can go 3 times 4, 12, times 2, which is 24. I can go 2 times 3, which is 6, times 4, which is 24. I can even do 2 times 4, which is 8, times 3, which is 24. Multiplication order does not matter, but it is not passed through like this. The reason I said it's a great question is because these are those like fundamental things that you have to understand. You know, I mean, but I don't know. It's a great question.
scenario where it wouldn't work, but
You're not going to be able to find it.
okay. Well, that's nice of it.
It is, and that's why I like mathematics, because you're not going to have this gray area of, oh, but it doesn't work this time.
Yeah.
You know? All right, I think that's it for grouping. You'll have to practice, right? So you have plenty of problems in your homework for practicing that. Now let's get on to this whole factoring thing. We say, all right, look for the GCF first, then how many terms. If we have 4 terms, we have a way that might work. What if we have 3 terms? If 3 terms, then we do what we call the AC method with grouping. Okay, so 3 terms, that's not on camera, so I'm going to put it here. 3 terms, which we call trinomials. Then we use what's called the AC method with grouping. Now look, you may already have seen how to factor trinomials from high school. You may have a way that works with you. In fact, there are going to be some people in here who know a method called just kind of like guess and check, where they're just like mentally trying to make it happen. And if you're comfortable with that, great. This is a method for people who really just, right now, don't feel comfortable factoring trinomials, and I need to give them kind of a lifeline. Here it is, here's how you can do it systematically, all right? So let's look at our first example. X squared minus 6x plus 8. All right, the instructions here are to factor. So just, I know somebody in here already knows what this is. Can anyone know? Just by looking? Okay, what do you got?
17x plus 2.
I agree with the 2. Minus 2 minus 4. You have to get a negative 6 in the middle, right? Okay, but you obviously it's in there. You just got to sort through a couple of little things. Okay, so that is the correct answer, all right? That's not the AC method with grouping. I'm going to show you that, but let's just see what we have. If we're asked to multiply this out, you get what here? X squared, you get minus 4x, you get minus 2x, and then you get plus 8, right? And if you put that together, you would have this, right? So the question is, how do we go from this to this? And you have a way of doing it where you're just playing with the numbers in your head, right? That's what you're doing. You're trying to come up with 2 numbers that multiply to be this, but add it up to be this. And that's the AC method, basically. But here's a more systematic approach. So everyone realize that's where we're trying to get to, all right? So here's the more systematic approach. First thing, GCF. Make sure there's not a greatest common factor, right? And now what I do is I'm going to make this little, like an X. And this is kind of childish, but let's just go with it, all right? Up here, I want you to put the number 8, which is the last number you see over here, which is a positive 8, right? So I put plus 8 up there, just 8. And then the number in front of X, which is negative 6. And here's what I need. This is a little multiplication symbol, and this is a little addition symbol. I need you to mentally come up with two numbers that will multiply to be this and add to be this. So I think the obvious choices for numbers that multiply to be 8 would be 8 and 1, 2 and 4, right? Those are the only numbers that you can think of that it would multiply to be 8. But I need these numbers that we choose to add to be a negative number. So that means they both have to be negative. Like I have to have like negative 8, negative 1, negative 2, negative 4, right? Because two negatives multiply to be a positive. So which of these would add to be negative 6? Negative 2, negative 4, right? So I'm going to put here negative 2 and negative 4. And it doesn't matter. You could put negative 4 or negative 2, right? That doesn't matter. Okay, y'all with me? All right, the next step, after you've determined your two numbers, is you're going to rewrite the problem that you're trying to factor. You're not going to change this or this. You're just going to leave those. But that negative 6x that's in the middle, right, that negative 6x, you're not going to write it as negative 6x. You're going to use these two numbers instead. So you're going to write negative 2x and negative 4x. I think we would all agree that these two numbers, or these two terms together would get us back to this, right? So why would I do that? Why would I take that negative 6x and split it into two terms? Why? Now I've made it 4 terms, right? And how do we factor things with 4 terms? Grouping. I can do grouping on this. So we come in here with grouping. Do you see why we did 4 terms before 3 terms now? To do grouping, I slash it right past the second one, and I pull a GCF out of the first. So what can I pull out of this? An x, and that's all, right? So I'm going to have x in parentheses, what? X minus 2. And then do y'all like doing the one where we matched it? We said we're going to need x minus 2 here. And then what would I need to turn x into negative 4x and negative 2 into positive 8? Negative 4. And that is exactly what we needed, these two to match. And so we can write the next line, and this will be the answer, won't it? What is it? The thing they both have, x minus 4. You can write it that way, x minus 4 and then x minus 2. Or the other way. So really, to do this trinomial thing, this is the new step. This right here, and then splitting this into 2 pieces. Once you get here, it's now 4-term factoring, grouping. Now, I would prefer you do Bethany's way, which is to do it mentally, but that takes time, all right, to get to the point where you're comfortable enough to do that. If you're there, though, that's good enough for me. All right, we should try something a little more difficult, don't you think? Well, we'll do one more easy one, and then we'll do something a little more difficult. How about hold on. Factor that. You ready to have it? Yeah? Yeah. All right, so 3 terms, no GCF. Destiny, what number am I gonna put here, and what number am I gonna put here? So -6 here, and +1. All right, so let's see. Destiny, can you think of 2 numbers? That's all right. Okay, tell me the things that multiply to be 6. Come on. Just give me 2 numbers, 6 and 1. All right, and then any others that multiplied? 3 and 2. Okay, good. Now that you've got those, you need this to be a -6, right? So if I multiply these, that's positive. That's not going to work. So you got to make one of them negative. So which one would you like to be negative? It's up to you. Okay? So you could have that, or you could have this, right? Do either one of these, if I took 6 and added -1, or -6 and add 1, would I get 1? No. So it can't be those. Here, I still have to be negative, so one of these has to be negative, right? I could have this, or I could have this. Which of these would add up to be 1? Last one, right? So this is like 3 minus 2. So that's it. 3, -2. Got it?
Wait, if -3, if it was -3, then would it be -1?
I'm using this one.
Okay, but I thought you said that you can use either or.
I'm saying, okay, we had 2 and 3, or 3 and 2, right? That multiplies to be 6. I need -6. So it either has to be a -3 times 2, or it has to be a 3 times a -2. It's got to be one of these, right? But it can't be this one because that adds up to be -1. These add up to be +1. Understand? Okay. So now we got that. We rewrite this. I like to just rewrite the edges, right? X squared and -6. Put that first. Who's that, Lena? You look happy. You have a smiley face on your thing, so you look happy. Lena, I'm going to rewrite the x as what? Are you comfortable doing this without all this? Kinda? Okay. Well, you can still help. I'm trying to rewrite 1x, right? And I'm using these 2. So what should I write?
You can write -2
X.
and then +3.
Yes. And like I said earlier, it doesn't matter what order you put these in. Okay? And that's it. We're there. 4 terms, slash it, GCF. So what's the GCF on the first 2? X. What's left? X minus 2. Okay, here, I'll play the matching game. I need X minus 2. So what number must be on the outside of that? 3, right? 3 must be on the outside. And since it's +3, I put +3. Bless you. And I believe we'll be there at this point. I'm going to write what they both have in common, x minus 2 in parentheses, and then x plus 3. The good news about factoring is that you can always check your work. You can always go back and multiply this out. And if it multiplies out and combines together, and if you get back this, then you did it correctly. You all ready for the weekend? Yes? Good. It's nice this no classes on Friday thing, huh? All right. 5x squared minus 14x plus 8. All right, so even my students who are pretty good at this are probably going to have to think a little bit about this or write something down. Do I have anyone that can just knock this out right away without writing anything down? No? All right. I didn't think so. So these are more complicated. Always start at the beginning. We're trying to factor GCF number that goes in all of those. No? You don't have an X through all of them, so no GCF. 3 terms, AC method with grouping. Oh, by the way, the reason they call it the AC method, I didn't explain this, is that all quadratic trinomials can be written in this form, ax squared plus bx plus c, which we'll talk about later. These are called quadratics. That's the general form of a quadratic. And the numbers that we put in this box have to do with, I told you take that number and then this number, right? Well, this is the c, right? The a is out here, and somehow the a and the c are going to be incorporated here into this method. So that's why they call it AC method. Now, you haven't seen where the a comes in, but this is the first problem where you have to look at it. So, all right. I told you before that you would put 2 numbers here, right? And if you follow what I said before, you would probably write this, right? This is incorrect. Now here's why, all right? Here's why. The problems that we did before, we had a 1 out here, didn't we? It was always just x squared, x squared, x squared. What I didn't tell you is that what you were actually doing was taking the number back right here and multiplying it times the number there. And if this was 1x squared, it was always just 1 times that number, so it was just the back. For the proper AC method, what you have to do is take this number and multiply it times this number, and keep track of the signs. This is a positive times a positive, which would give you a positive, right? 5 times 8 is 40, and that's the number that goes here. This is A times C. Do you see that? That's A times C, the number A out here, times the C. Now, the good news is that the negative 14, that is right. You do keep that way. Y'all okay with this? All right, here we go. You have to think of a number that multiplies to be 40 and adds to be negative 14. So look, you just have to start making a list, 40 and 1. What else? 20 and 2. 10 and 4. Should I keep going? 8 and 5. Any further? That pretty good? Now let's think about the signs. I need to have a positive number here, but a negative number here. The only way I can get a positive number here is if both of these numbers are positive or both of them are negative. Do you agree? And I need a negative number here, and the only way I can put these two together and get negatives is if at least one of them is negative. So this is telling me both have to be negative, and this is telling me at least one of them has to be negative. So that means they both have to be negative. So do any of those add up to be negative 14? Negative 10, negative 4. Was that a question? Or? Oh, you want to keep going? Okay, so go ahead, Erica. You want to rewrite this for me now. What do you want me to write, Erica?
Do we keep how we did last time?
Yep.
5,
Yep. 5.
6, and
Then
Negative 10.
negative 10. Good.
then negative 4.
Good. Plus 8. There you go. That's it. Everyone see what I did? And now you group this. Slash it here. This is the young Einsteins over here, the young Einsteins table. Y'all didn't come up with names for your groups. Just you're the only ones. Leaders.
Maybe the old Einsteins.
You can be the old ones. So what are we going to do on that first one? What are we pulling out? 5x. Right, you're going to pull the number also. So 5x. What's inside the parenthesis?
X.
X minus 2. And then you need to match the same thing over here. So if this has to be x minus 2, and I've got to turn an x into a negative 4x, then my only option is what? Negative 4. And now I'm going to just check. -4 times -2 is +8. This works. So my final result can be written two ways. This one, or if you'd like, you could do it the other way. How we doing? Y'all all right with this? I'm going to have to give you some to do on your own, of course. You do this one. Let's do it on a separate piece of paper. Just put your name on it. You may speak with each other if you wish. All right. I'm going to give you 10 minutes. We're going to restart class in 15 minutes. Okay, at 1:50, I'm going to restart class. Right now on my watch says 1:35. So if you finish that up, you can take a break till 1:50. Or you can take the whole 15 minutes and then you're not going to get a break. Factor this. Oh, and you're going to turn it in. This is going to be your second quiz grade of the day.
I noticed that doing my percentages wrong. Like when they're asking me for the percent, right? I know that that's 0.10 of the 1 whole liter. When they want to know the whole combination of the 3, I'm doing 0.10 times the 3, right? Liters?
Which one is this one? This is where,
The
okay.
homework on everything.
Yeah. No, you're doing the point. So this is how many liters, 0.10 times 1 is how much butter fat milk you have, right? And your total liters is 3. You want to know 0.10 is what percent of 3 liters. So what you do is you turn this into an equation. 0.10 is what percent x times 3, and then you divide by 3. 0.10 divided by 3 is x. I think you said you were multiplying.
So was this right?
0.33. Yeah, I think so. Yeah.
Okay.
Yeah, but this should be times right there.
Times?
That should be times.
Okay, that's where I'm getting it wrong.
Yeah. Okay, let's get started. Y'all ready? Y'all ready? Pokemon, we can, if I say Pokemon, everyone just starts blowing up. Everyone goes crazy. What's that? I don't know, is it Pokemon? Pokemon what? Oh, sorry. Sorry about that. I don't want to offend anybody. Pokemon. I have a question for you up here. It's math related, but it's definitely not something that is you'll be tested on, but it's something to consider. I'm curious what your responses are going to be to this. What's 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 forever?
Yes.
The answer is yes? What do you think?
Wait, I forgot to
You did what? Return it? 1 minus 1 plus 1 minus 1 plus 1 minus 1 forever. What do y'all think? Infinity? Okay.
0.
0?
-1.
Negative 1?
+1.
23?
85.
I mean, really, you look at that, maybe you don't care, and that's fine. But I'm just curious, like, what you might think that is. 0?
That's my final.
That's your final? It doesn't, it never stops.
Then, is there an answer?
That's a great answer. Is there an answer?
Plus minus 1.
So it could be either plus or minus 1? Okay, so look, how about this? Let me try and convince you of a possible solution to this. Let's just call this S. All right, let's just call that S. S for sum. Okay, that's a sum, isn't it? Okay, I'm going to write S again. I'm going to write it below. I'm going to write it this way, though. Well, it's the same thing, right? Because if you add 0 to something, it's the same, right? Now what I'm going to do is I'm going to add these two equations together. So in other words, I'm going to write S, and I'm going to double it. I'm going to add it to itself. S plus S. If I take S and I add S to it, how many S's will I have? 2 S's. So do you agree that 2 S's should be this plus this, this plus this, this plus this, just adding them straight down? Okay, what's 1 plus 0? 1 What's negative 1 plus 1? 0. What's the next one? 0, 0, forever. And so what we get is that 2s equals 1. And if I ask you to solve that for s, you'd divide both sides by 2, and you would get 1/2.
But I feel like that's like irrelevant to figure out another s, like 3s, right? So then it'd be 1/3.
Well, if you add another s in here, where are you going to put it?
You just add.
Where do you want it to be? Where?
So it'd be 0, 0, 1.
You want me to do 0, 0, 1?
Well, I'm just saying.
No, this is a good proposition. If I did another s, how would you line it up to make all these zeros? I don't think you're going to be able to do that. Right? Because if I did 1, negative 1, 1, negative 1, then I'm going to have things other than 0 that time. Yes?
Why did you put the 0 at the start?
Because I knew it would work.
Well, yeah, I know, but like, what specific reason is the 0?
Because I'm trying to make you think about something that doesn't feel natural. I'm trying to give you something that you don't like up here. All right? Here's another one. 1 plus 2 plus 3 plus 4 forever. What do you think about that one?
I feel like I would just put a greater.
What's that?
That's not in the hall.
I don't know, is it?
It is over there. It's going
Is it?
There is something like that right there. Yeah.
Right here?
I just don't even pay attention.
Right around the corner.
Really? I'll look. I'll go look.
That's in there?
I'll go look. Huh, that's interesting. I didn't even know that was there. Y'all know what this one is? Negative 1/12. What? Does that make any sense? No. That makes no sense, right? You have a bunch of positive numbers, you're adding them up, they're getting bigger and bigger, you do it forever, and it gives you a negative fraction. If you go right now, which I know none of you are doing, but if you were to open up a textbook on quantum mechanics or quantum physics.
I read that yesterday.
Got it? Okay. This is usually in the first chapter, is that you have to assume that this is true. And all of the quantum theories are based upon this summation being true. And what's interesting is that in the real world, in the physical world, when we test things and we take readings, we actually come up, this sum appears. And when we replace that sum with negative 1/12, all of what we see and observe matches with the mathematics. It works in the real world. It's very strange. We can't really explain it too well, but there's a proof. I could show it to you. I'm not going to. Of kind of like how I did with that S thing, and just add another S, and I could do that and show you this is true, but it would take about 10 minutes. So, okay. Hopefully that shifted your brains off of Pokemon for a minute. Let's continue factoring. Pokemon. All right. So what if we have two terms? If two terms, we use a special formula. I could tell as soon as I said quantum mechanics, everyone was like, who cares? But I think it's somewhat interesting that a lot of the modern day physics is based upon some pretty absurd ideas that don't really make a lot of sense. But it seems to work. So, do y'all want to do this, or should I keep talking about quantum physics? Quantum physics. Wow. If you have two terms, the only thing that we are going to look at in this class is if you have what's called a difference of squares. So in order to factor two terms, a two-term expression, we must have a difference of squares. That means it must be something squared minus something else squared. If that happens, we can do it. So here are some specific examples of difference of squares. X squared minus 49. Another one, x squared minus 81. X squared minus 25. These are all difference of squares. Right? You have two terms in each of these. This is a number squared. This is a number squared also. It's not as obvious because it's not written as squared, but it's 7 squared, right? This one is 9 squared, and this one is 5 squared. I'm pretty proud to say my 7-year-old daughter knows all her perfect squares up through 15. It's pretty good, right? I don't even ask her. She just wanted to learn it. I was like, we started out with like 1 times 1 and 2 times 2 and 3 times 3. And every night when we go to bed, she's like, okay, let's do the squares. And I'll quiz her. She'll be like, don't give them to me in order. And I'll give her to them like, 7 times 7. And we're every few nights we add another perfect square. Yeah. So, but now I'm having to like get my calculator out and like double check. I'm like, okay. Of course, because I really only know like up to like 12, and after that I don't care, That's all you really need most of the time, up through 12. You're good? Okay. All right, so these are perfect squares. Sorry. And because of that, what's the formula for it? Does anyone remember what it is? I didn't put it down up here. Oops. It's always going to break down to be 2 factors. It's going to be the x plus the x minus the a. And it doesn't matter which way you write those. X plus a, x minus a. So for us, in this problem, we would write that as what? X plus 7, x minus 7. Done. It's factored. Next one. X plus 9, x minus 9. Next one. X plus 5, x minus 5. Got the pattern? If this is a plus sign, there is no way to factor it. It's not factorable. Got it? There are also 2 more formulas that we're not going to cover in this class. There's a difference of cubes. There's a formula for it. And there's another one with the plus sign. You can actually, there is a formula for this one also. So we won't focus on those. Just be aware that they do exist.
So it's only when it's
Yeah, when you have the cubes, there's a formula for both. When it's squared, there's only a formula for subtraction. So let's do a... If it's a plus, you can't do it. So if someone wrote down, hey, break this down, factor that, you'd actually say it's prime, not factorable. All right, so let me give you a problem. X cubed plus 3x squared minus 9x minus 27. I would like for us to factor this. So what are you thinking? Greatest common, good. Who said that? Good. Greatest common factors first, right? Don't forget that. GCF, do we have one? No, right? Don't have a number or a letter in all of them. So move on. Terms? 4 terms. Grouping. What comes out of the first one? X squared. What's here? X plus 3. Good. Next one. Do y'all like that matching thing where we just write it? Okay, let's just do that. And now you have to turn x into negative 9x. Your only option for that is negative 9. And just double check, negative 9 times 3 is negative 27. So it works. What is the next thing that you write? You had 2 options on how to write this, don't you? X plus 3 minus 9. and you box that up and you turn that in and you don't get full credit. Why? Ah, that's a difference of squares. See, I hid it in here. See the difference of squares there? X squared minus 9. That breaks down further. This one doesn't, right? Because it's not even a square, so you don't have to worry about it. But this other one turns into two things. And what does it turn into? X plus 3 times x minus 3. Huh. Now it's factored completely. And you can even go one step further. You could put x plus 3 squared times x minus 3. That would be completely factored in the cleanest notation. Do you see these are the same? I'm not multiplying them together and doing FOIL, right? I'm just saying, hey, look, anything times itself is that squared. So I'm just rewriting that notation. How about this? 81 minus x squared. Can you factor that? Yeah, this is the same as 9 squared minus x squared, right? So do you agree that that's still two things squared, subtraction between them? So it should look a lot like what we just did. What's different though? It's instead of like this, where we did x plus 3, x minus 3, they're switched. So it should be 3 plus x, 3 minus x. Notice how they switched roles. It does matter, yes. Well, maybe. How are you going to write it? Were you going to write it like this? Yeah, that wouldn't work. Because if you wrote it like this, you're saying you would write it like this, right?
No, I was going to do x plus 9 x minus 9.
Nope, not 9, because then it would be 81. Oh, shoot, I'm sorry. I'm sorry. That's my fault. It's my fault. Sorry, my fault. How are you going to write it? This way? That's still not going to work, though. This doesn't work, sorry. But mine was way off, okay? This, when you multiply this, watch what happens. 9 times 9, 81. 9 times negative x, negative 9x. X times 9, positive 9x, so those are gone. 81 minus 9x plus 9x minus x squared. That's what you would get if you multiplied those out. These two would cancel, you get 81 minus x squared. If you do it this way, then you get x squared minus 81. And that's not the same, right? X squared minus 81 is not the same as 81 minus x squared. So if the order changes, all you do is you just switch them in here too. All right. That's it for the factoring. And now we are going to do solving quadratic equations. Pardon? I don't think so, no. Solving. Let me see yours. Is that the one you bought in the bookstore? Let me see yours. I thought I checked these before. Go back on here. We're doing this right here. Yeah. Yep. We are going to solve quadratics more, okay, later, but now what we're doing is solving quadratic equations with factoring. So what's the purpose of this whole thing of factoring? Like, why do we do it? What's it useful for? And it's for solving quadratic equations. Yes. We're still on, let me look at yours. Page 30, page 55, part C. This right here.
Yeah.
That's what we're doing. Yep, and one on, no, yep. All right, so let's talk briefly about what a quadratic equation looks like. Any quadratic equation looks like this. I like, when possible, to at least give some meaning to why we would want to do something, especially in a class like this when everyone's like, well, what are we doing here? So let me try and motivate the idea a little bit. Does anybody know what a quadratic function looks like if you graph it? What does it look like? What do they call those things? Parabola. Y'all heard that before? Parabola? If you were to sit there and graph this, in other words, if I were to write y equals this. We saw that, like, if it was y equals mx plus b, it's a line, right? But if it's y equals that quadratic thing, it looks like a parabola. And parabolas look like this. They look like U's. And we usually say they open up or down. We're going to talk more about this later, all right? I just want to kind of introduce why we're doing this. And these are very, very useful to us, believe it or not, all right? Now I'm going to give you a demonstration of why. You want to help me out, Sean? You don't have to get on camera. You just have to go stand over there. Sean's going to help me out. All right, Sean. So I'm going to throw these to you, and you're going to catch them. All right? I'm going to toss them. All right. So just watch the markers go through the air. All right? All right. Good. Good job. Okay, throw them back. Oh, okay, try and lob them up a little bit. There we go. Okay, good. So, good, perfect. All right, so the path of those through the air, right, is curved. And it's not just any curve, it is a parabola, guaranteed. There's no question about it. It has to be a parabola. So it could look like this. If you lob it really high, it could look like this. It just depends. If you throw it really, really high, it's going to look, something like that. And so, as humans, we've, over time, realized that the things that we observe physically can be modeled mathematically, and a quadratic function is the way you model things flying through the air. Now, why is that useful? Well, I'll tell you probably the most useful part of it, or what motivated it the most, and that was back in the day when you had things like a castle. This is a castle, okay? That's a castle. And you want to attack the castle, you want to pillage, you want to take all the food and, kill the people that don't agree with the way you believe and all that stuff, right? We love that shit, don't we? Don't we like that, humans? We do. Okay, so if you want to effectively tackle that, you can just start lobbing stuff at it. You can start throwing, cannonballs and whatever. But at some point you realize, you know what, I can be a little better than just hope I hit. You can actually hit where you want to hit. If you understand the mathematics behind the projectile, what its motion is doing, right? Then you can accurately put it where you want it. So that motivation of wanting to, unfortunately, wage war upon each other has motivated mathematics in ways that it would have never advanced, right? Think about the atomic bomb. What was the motivation of that? We better get it before the Germans get it, right? Or else we're screwed. So it was that need, right? So understanding a quadratic function helped us do that. And then now it's everywhere, right? You're on your phone, right? How is your phone communicating? It's sending signals through the air. And you've got these satellites that are catching them. all satellite dishes have a little thing on the inside, right? They're all curved. If you were to cut this open, it would be a parabola. And the property of a parabola is that if you've got things going into it, it bounces off, and everything bounces. Just the way it's curved, it's perfect. All the things that go in bounce, and they all go to a single point. That's called the focus. Now, if you take a basketball and you cut it in half, it won't work. It's not shaped properly. It has to be parabolic. It has to be quadratic. So we realize that, we discovered this, and we use it, with our communications to this day to wage war upon each other. It's wonderful. Okay, so with that in mind, knowing that parabolas are useful to us, we are going to eventually want to know what the x-intercepts are. And x-intercepts of a function, like we did with the lines, we always said, okay, to find the x-intercept, you set y equal to 0. So if we were to treat this like a function, y equals that, and I ask you for the x-intercepts, you would replace y with 0, yeah? And when we do that, we have a quadratic equation, and we're going to try and factor it and solve it. Okay, so let's do this. Before I can do it, though, I have to make sure everyone is on board with this. It's called the zero factor property. This is a major property. We don't want to take it for granted. All right, if I tell you right now, A times B equals 0, what can you tell me about A and what can you tell me about B? Or can you tell me anything about them? What's that? One of them has to be 0. One of them has to be 0. So if A times B equals 0, then A equals 0 or B equals 0. One of the two have to be 0. There's no other way to do it. Can anybody try and come up with a way to make two numbers multiply to be 0 without one of them being 0? Negative 1 and 1. But it's multiplication. So that's going to give you negative 1, right? It's a good try. It would work with addition, right? But not with multiplication. So you can sit there and you can try all day long. You're not going to ever come up with it. All right? So two numbers multiply to be 0 means one of them has to be 0. What if I added a third number in here, times C? One of the three, right? A, B, or C have to be 0. If I have four things, one of the four things has to be 0, right? The important part of this is they call it the zero factor property for a reason. This is the key to it all. 0. Let me show you something different. What if I tell you that two numbers have to multiply to be 2? What can you tell me about A and B? Does one of them have to be 2? No. Doesn't have to be. Could be. Right? I could do this. 2 times 1, and that would give me 2. Okay, so look, one of them was 2. But do one of these have to be 2? No. Give me an example of two numbers that wouldn't be 2 that would give me that. 4 times 1/4 is 2, and neither, right? That's 0.1. That's 0.25. I'm having lots of these today. 8 1/4.
Or 4 times 1/2.
Or 4 times 1/2, like you said. Sorry. Right? So yeah, 4 times 1/2 is another example. So look, you can sit here all day long and you can come up with examples of two numbers that multiply to be 2 where neither one of them is required to be 2. All right? So this only works if this is a 0. And that's why it's going to be so important for us when we're looking at quadratic equations that we always make sure they are set equal to 0 before we begin. So keep that in mind. And we get to the first example. 9x squared minus 16 equals 0. So is it a quadratic that is set equal to 0? Yes? This is a quadratic, isn't it? X squared, that makes it quadratic. It's set equal to 0, so we're in business. We just need to see if we can break down the left side into to be something times something. Right now it's something minus something. But that's what factoring is all about, right? Does anyone know how we would attack this? GCF, do you have GCF on the left side? No? How many terms? 2, okay, special formula? Difference of squares, that's all we've got. Is that a difference of squares? Is it something squared minus something squared? Isn't this 3x squared minus 4 squared? I'm writing the 4 in parentheses even though I don't need to. Yet the thing you have to be careful for is this 9. When you square 3x, you square the 3 and you square the x, which would give you 9 and then x squared. Minus 16, which is 4 squared. So using that formula that we had, what would we have in these two parentheses? What would go here? What would go here? 3x minus 4, that's fine, and then 3x plus 4. And you could do it the other way around. You go 3x plus 4 and 3x minus 4. All right, Joshua. You look like you need some motivation. What are you going to do with that, Joshua?
That would fit what we needed, and one of them would have to be equal to x, or 0.
That's right. You have two things that are being multiplied together here, right? A is this big chunk, and B is this big chunk. They're being multiplied together to be 0. That means one of them has to be 0. So let's investigate that. At this point, either 3x minus 4 equals 0, or what? 3x plus 4 must equal 0. Do you see, this is where I'm using the zero factor property. And since Josh is on a roll here, Josh, well, you wrote Joshua, so I'll go with Joshua. Joshua, what types of equations are those? Linear equations. And how do we solve linear equations? We isolate the x, right? Isolate the x. So now we're back to stuff we've done before, right? So here I'd move the negative 4 to the other side, which would make it positive, then divide by 3. X is 4/3. Over here, move this over to become negative, so negative 4/3. So you might have to do a little bit of work, but you should get to those two results. So what we're saying is for this equation to be true, right? For this to be true, either x has to be 4/3 or x has to be negative 4/3. If you replace it with that, then it should be true. All right, let's do another one. How about 4x squared equals 11x plus 6? So now we want to start to really focus on, thinking what type of equation am I looking at? So you look at this, right? It's an equation because there's an equal sign. It's x squared, not just x, so this is quadratic, right? What is the method so far that we've developed to solve a quadratic equation? Set it equal to 0. So that means you got to get everything to one side. And it's up to you, left side or right side, it's your call. I'm just going to move everything to the left. So when I say move everything left, what does that mean? Switch the signs, right? Subtract all this, put it over there, it becomes negatives. Hold on. Did I write that down right? Sorry, let's make this a minus 6. Minus 6 here. Everyone got that? Change that to a negative. So when I rewrite this, it's 4x squared minus 11x plus 6 equals 0. And keep in mind that when I wrote this down on the left side, when I rewrote it, I put it in what we call descending order, which meant I went from the highest power of x down. Okay, so x squared, x, and then no x's. That's called descending order. Now what? Greatest common factor. So we're going to start trying to factor this out. We tried GCF, no go. Okay, how many terms? 3. So we try AC by grouping, unless you can do it mentally. AC by grouping is going to be what number up here? 24. Number down here? Negative 11. What if you can't come up with these numbers? What if you just cannot come up with these numbers on your homework and you're stuck? I want you to write prime. That would mean it doesn't factor, and it could happen on your homework. But make sure you've checked all your numbers, because it could be that you just can't find them. That you didn't check thoroughly enough. But if it does not work, just put prime as the answer. Doesn't factor. Does it work in this case?
Yes.
Yes. What are they? Negative 8 and negative 3 again. Negative and negative. That will work. Pardon? Good? Okay, so what I'm going to do now is I'm going to rewrite this trinomial over here. And I'm going to rewrite the negative 11. I'm going to do my 4 terms. I'm going to do my grouping. And then, so I'm kind of building off of what we've already done today, right? What did I say would happen if you switched the order? You put the negative 3 and then here and then negative 8 here, and you switched them here. It should still work, okay? You should still be able to get to it. So this, sign-in sheet is coming around. Remember, you're allowed 2 absences. You're allowed 2. I think what was the highest grade on the test? Was it 98.6 or something like that? If the people who got like the highest 3 grades in the class had missed more than 2 classes, I might talk to them about, okay, that's okay. But if you're missing 2 or more classes and you're in the 70s on your test, then that's going to be a problem. I'm talking while y'all are finishing this up. Who has this? You want to share?
I got 4x minus 3. And x minus 2.
Agree? Agree? All right. Looks good. You could always check, right? You can just check. I like to do quick little checks. This is 4x squared, so that's good. This is going to be negative 8x and negative 3x and negative 11x, good, and negative 3 and negative 2 is 6, so yeah, it works.
Is that going to be the same if you were to do it, like you subtracted the
If you subtracted the what?
4x squared for the beginning, like instead of moving everything?
If you would have moved it to the other side?
Yeah, but it's still
It would work. It'd be a little tricky, but it would. You'll get the same answer. You would not get the same factors. These factors would look different. The question that's being asked is, what would happen if you would have taken this to the other side? Right? That's your question? Yeah. Your AC method would have looked different too. You would have had, let me see. Well, no, 24, and you would have had positive 11. So things would change, and numbers. It would be a little tricky, but at the end of it all, we should have the same answers. So what do I do at this point? Set each of them equal to 0. So 4x minus 3 equals 0. And then x minus 2 is 0. And then solving each of these, 3/4 and 2. So it's either 3/4 or 2. One more. Mm-hmm. 30x cubed equals 2x squared plus 4x. Uh-oh. So you should probably be looking at that saying, hey, that is not a what? Quadratic equation, because it's not squared. It's not squared, right? The highest thing you have there is cubed. That's bigger than squared. Yes, so the question is, what do you do with this? And our technique is going to be exactly the same. We're going to move everything to one side and let it equal 0. All right, start with that. So how about I move everything to the left side? Subtract. Put it in descending order, and you should have that. Are you all comfortable with that step, just moving everything? All right. Now we said, the zero factor property said A times B was 0, but I also told you that A times B times C is 0, and I said A times B times C, C times D. The more I add, it doesn't matter how many things multiply to be 0, you would just keep setting each of them equal to 0, right? If it's 2 things or 3 things or 4 things. So when we look at this trinomial, we look at the GCF first to try and factor, right? And I believe we have a GCF here. What is it? 2x. We can actually pull 2x out, can't we? So 2x comes out. How many terms will we have in there? 3 terms. What are they? 15x squared minus x minus 2. That good? Everybody sign in? What am I missing here? Equals 0. Let's not forget we have an equation. And now, this is a trinomial in here, right? AC method on that trinomial. Y'all understand what I'm doing? On this trinomial. The 2x I'm going to ignore, but I'm not going to forget it's there. What goes in that little thing here? Negative 30. We got that from doing the 15 times the negative 2, bless you. See, I'm ignoring this, bless you. I'm ignoring this completely, and I'm working with just that. 15 times negative 2, negative 30. Number in the middle? Negative 1. Okay, so now you get to play your game, try and come up with 2 numbers that multiply to be negative 30 and add up to be negative 1. You sit there, you punch away in your calculator maybe, and eventually you figure out it's negative 6 and positive 5, right? And that allows you to now break this thing down. Got to keep the 2x out there. So we're going to have lots of parentheses, and if you wanted to use the brackets, you could. I'll do this one with brackets just so you can see it. 2x is on the outside. Then I'm going to rewrite the 15x squared as 15x squared. Instead of minus 1x, I'm going to put what? Minus 6x plus 5x. It's using these 2 numbers. And then minus 2, and then I'll close my bracket off, equals 0. And we did all that for what? Why did we do that? I forgot why we did that. So we can group it. And then we group the inside. What do you have as far as a GCF here? Just x? 3x, okay. 3x, you can pull more out. So 3x, 5x minus 2 is what you would have here. So checking it, yep, you get that back. How about over here? Ooh, this one's tricky. We haven't seen one like this. But this is a very important problem. That's right. So we know that we need this over here, right? But you have to have something out here. You can't just leave it empty. So we put plus 1. See, because it matched up. So 1 times this is this, 1 times this is this, and we're in business. Close the bracket, equals 0. Does anyone have any questions over that step? That's pretty important. Yes?
Why do we need the 1? I mean, it's obviously going to just be 1 if there's nothing there.
Yes, well,
We'll use it later.
are we going to use that? We're going to say it's going to be this times what? 3x plus 1, right? So if you don't have that there, you might forget that. You might just write, like, I don't know what you'd write. I've seen everything, okay? I've seen people forget it completely. So you see what I'm saying? Like, you're going to do 3x and then
Well, it'd just be plus with parentheses.
what? Be what?
It'd just be plus.
3x.
Need a plus sign.
You mean you need a plus here? You're saying just put a plus there.
Yeah.
Okay, so what are you going to put here?
You would need the 5x minus 2.
Okay.
Yeah.
And then what goes here? See, that's why it's so important to put plus 1 out here, because what goes here is 3x plus 1. It's this, and then it's this and this in a parenthesis.
That makes sense.
Okay. I'm trying to sell you on it.
Yeah, I know. I was just trying to understand the logic on why you need
Yes.
Yeah.
It technically doesn't have, the plus sign has to be there, the 1 doesn't. But it's good to put it. All right, so we rewrote this as this, and then remember we had the 2x out here. I got rid of the brackets because it's all multiplication now. And so, there we go. Now set each of those equal to 0, right? There's 3 things being multiplied. So I'm going to have 3 equations here. Here they are. 2x must equal 0. 5x minus 2 must equal 0. And 3x plus 1 must equal 0. Those are my 3 equations. To solve the first one, I just divide both sides by 2. 0 divided by 2 is 0. Here we move the 2 over, divide by 5, we get 2/5. And then here we move the 1 over and divide by 3, we get negative 1/3. So in order to make that equation true, the very beginning, you would have to let x be one of those 3 numbers. All right. Well, it's been a long week, 4 days in a row with an exam. It's over. Please do the homework. I want to be specific, so because these things aren't matching up, I want to tell you exactly what the pages are on, or what pages to do. If you're working off the printed version, off the one I provided online on Canvas, which is the one that I have, it's page 59, and you should do 1 through 17 in part, oh wait, why doesn't it say part A? 1 through 17, and then 1 through 19. So both sections.
You only have 2 sections?
Pardon?
You only have 2 sections?
Yes.
You have 3, or A, B.
Hold on a second, hold on. And then if you're, can I borrow yours? If you're on, this is the printed one. This is the bookstore one. Page 57. One through 124 or 23. Is that fair? No. I'm kidding.
Oh, dang.
Y'all are screwed. Haha. Okay. Page 7, just all of them on page, seriously, all of them. It's 17, it's 17 problems followed by 16 problems. So it's roughly the same, right? So just do everything on that page. Just, that's it, right? Because that's all we covered today, right? Make sure you do that by Monday, though, all right? So I can answer questions at the beginning of class. Let me turn my camera off, and then I'll answer questions.